Hello, welcome to a triple science lesson, which is part of the organic chemistry module on alcohols and carboxylic acids. So first of all, I'd like you to, if you haven't done so already, pause this, print the booklet, or you can write on paper and do the following recall questions. So pause it now and do those. So moving on, the definition of an element, it contains only one type of atom. A compound is two or more elements chemically bonded, and a mixture is two or more substances not chemically bonded. The dot cross diagram for hydrogen should show two circles with two crosses on the overlap. That's a hydrogen molecule. Methane should be one carbon, has 4 electrons in its outer shell, and then it shares an electron with 4 hydrogens. Oxygen is a double bond, so it should have 4 electrons on the bond, and then the 4 remaining electrons in each shell. So I'm going to start with alcohols. So alcohols are a group of chemicals in organic chemistry. They all contain an oxygen as well as the hydrogen and carbon. The alcohol group, or what we call the functional group, is OH, which is an oxygen with the hydrogen. They form a homogeneous series. This basically means they all have a similar structure. To name the alcohol, you use the beginning of the name is from the number of carbons. So it follows the same pattern as alkanes and alkenes. So 1 carbon would be meth, 2 carbons would be eth, 3 carbons would be prop, and so on. The second part of the name is ol. So methanol is the smallest alcohol. Then you've got ethanol, propanol, butanol, pentanol, hexanol, and so on. Past 5, so past pent, or from 5 upwards, you go into maths names: pentanol, hexanol, heptanol, octanol, etc. So have a quick go in your booklet, match those up, pause it, match those up. And hopefully you've got these. And we would draw the structural diagram for methanol would look as I've shown you on this slide. So you've got carbon with its 4 bonds. One of those bonds joins to an oxygen, and the oxygen then joins to another hydrogen. And then you have the 3 other bonds for the carbon are hydrogens. You write as CH3OH. You always have the O and the H on the end to show it's an alcohol. So they all have the same formula. It's CnH2n plus 1 OH. So methanol, that, ethanol, propanol, etc. If you quickly try and answer those in your booklet. So pause it, answer those 2. You should remember this hopefully from Dr. Taylor's work with you. Here's the generic tables. So this is why they're called homogeneous. They have a very similar structure, very similar pattern, each molecule just being slightly larger than the next because of the extra carbon and the subsequent extra 2 hydrogens added on the chain. Okay, so the next, you're going to fill in this table yourself. The next slide, hopefully, if it's all attached properly, will be a little video showing you how to do it. So click on the image to play the video. There's a wider range. Fortunately, on these diagrams, you can't get the little bond between the carbon and the hydrogen that's above and below, but if you imagine they would be there. So, properties of alcohols. They are all extremely flammable, they're fuels. As with any substance generally, as they get larger, so the number of carbons increase, the density or the heaviness increases. All of them are poisonous. And then there's some standard reactions that they carry out. So an alcohol will react with sodium to form sodium ethoxide. If it's reacting with ethanol, if it's reacting with pentanol, it'd be pentoxide, and so on. So that's a generic reaction of an alcohol with a reactive metal. Smaller alcohols will dissolve readily in water, so they're often used as solvents. So if something doesn't dissolve in water, which is the universal solvent, you can normally dissolve it in an alcohol. To produce alcohols, you react, there's two methods. You react the alkene with steam, or you can ferment sugar. So like beer making, wine making. They oxidize easily, and they will turn into carboxylic acids. So you can do this, you can force this to react quite quickly, or you can allow it to just oxidize slowly in the air. So if you try and list the four properties, and then I'll run through the answers in a minute. And then you can try a balanced equation for the complete combustion of methanol. If you pause it, fill that in your booklet. So those are the main properties. And here is the balanced equation for the combustion of methanol. You should know from your work with Dr. Taylor that complete combustion produces carbon dioxide and water. You should have been able to work out the formula of methanol, and obviously in combustion it reacts with oxygen, and then you balance it. Two uses for alcohols. Main uses are as fuels and as solvents. The two methods for production of ethanol is they will react with steam to produce an alcohol, and you can ferment sugar solutions. The optimum conditions for fermentation, which you probably haven't done for a while, are 37 degrees C in a slightly acidic solution with limited or no oxygen. You pause it there and do the slop, or you can go back and do the slop at the end of the next bit, but I'll leave you to do that in your booklet. And the second part of this lesson is on carboxylic acids, which basically are naturally occurring acids. So ethanoic acid is vinegar, formic or methanoic acid is what you get in ant stings, citric acid is another organic acid. They react in all the ways that acids do, but they're just a lot weaker than the laboratory acids that we use. So if exposed to the air, ethanol and any other alcohol will oxidize. For example, ethanol or wine goes off if you leave it with it spun out. The sour taste is caused by the production of ethanoic acid. And again, in this group, the functional group is COOH or COO. So a carboxylic acid is written with that at the end to show it's a carboxylic acid. So naming the carboxylic acids, again, the stem of the name comes from the number of carbons, and the ending has oic on the end, acid. So for example, the smallest is methanoic acid, which is 1 carbon. Functional group, as say, is COO. Have a go drawing methanoic acid. Pause this and have a go drawing methanoic acid. So it's drawn like that. You draw your carbon, you draw your COO bit, which is a double bond to one oxygen, a single bond to the second oxygen, and a single bond to the hydrogen, and then the remaining carbon bond, the hydrogen goes on it, and it's written in the, as shown on here, HQ. Ethanoic acid, another carbon, but again ending with the Q on the right hand side. So have a go at the table, pause it, try and fill in the table. So you've done methanoic and ethanoic, have a go with propanoic and butanoic. If you want to check you're right, you can play this little video on this slide, which has got them drawn up, the other ones drawn up. Reaction of carboxylic acids. So they will react with metals to produce hydrogen gas. This is a lot slower than a laboratory acid because they're a lot weaker acid. They will react with carbonates to make carbon dioxide. They will dissolve in water to give a pH of about 5, but their pH can be anywhere between 4 and 6. And they often have an acidic or tart smell, for example, vinegar or lemon juice. They are not flammable. Have a go at these questions, fill them in your booklet. Pause it, have a go. So the functional group is Cu, and they are weak acids because they only partially ionize or only partially dissociate, and their pH range is between 4 and 6. Have a go at these two. When a carboxylic acid reacts with a carbonate, you will get a salt, water, and carbon dioxide. If sodium carbonate reacts with ethanoic acid, the name of the salt would be sodium ethanoate. So just like sulfuric acid makes a sulfate, ethanoic acid makes an ethanoate. Methanoic acid would make a methanoate, and so on. So it's just a standard pattern. The slot questions in the book, have a go at them. Thank you for listening.